equation and different cases of ideal gas equation we have taken. Now come to the second part, another part of gaseous state. Still we have two more laws which are suitable for gaseous state. Let us try to understand that one. Today we'll discuss one and the next we'll start in the next class. Come on. Suppose for example you are discussing about a situation, something like this. You are having, suppose, a container of volume V. In this container, you have taken gas A and you have connected a manometer. Right, definitely there will be some reading because of this gas. Open-end manometer I have taken, right? Now, once you're having this one, then how do you tell it? Sir, I call it as pressure of gas A. What is the name? Pressure of gas A. Nice. Suppose, for example, you said, okay, I'll do one thing, sir. I have taken another container, but volume is same, V, and I have taken gas B here in this case. Suppose, for example, you have taken gas B, and then you have connected a device known as manometer to measure the pressure. Okay, this is pressure manometer. Reading is, say, for example, somewhere here. We say, sir, this is known as pressure of what? Gas B. Right. Now the question is, who is responsible for this? Right. That is pressure because of A, because of B. You will say very simple, sir. Whenever we are talking about gases, they do have molecules, and all these gas molecules collides with the walls of the container. Collision force of collision per unit cross-section area of the gas container is known as pressure of the gas. Very good. Nice. Now suppose, for example, I have taken a third container whose volume is again V. And in this container, suppose, for example, I have taken gases A and gas B. Both of them, here I am having N1 number of moles, here we have N2 number of moles. N1 moles of gas A, N2 moles of gas B, both of them are added, but volume is kept constant. And of course, temperature is also constant because I am doing experiment under similar conditions, temperature, room temperature, right? Now, suppose, for example, if you attach a manometer, then what happens? There will be some reading here. And what you should call this reading? This reading is called total pressure of gas mixture. Total pressure of gas mixture. Right? That's all. Simple discussion. Now let us try to think over it. Sir, pressure because of A, first container, due to collision of gas molecules. N1 number of moles. Suppose if I increase number of moles, 2N, collision will be more, force is more. If number of moles are less, force will be less. Okay, this means to say, if you are increasing the number of moles of gas A, if you are increasing number of moles of gas B, their corresponding pressure is also increasing. Come on. Suppose, for example, if I have taken mixture of gas A and gas B, I am getting some value known as total pressure. Then my question is, who is responsible for this total pressure? You will be giving systematically answer, sir. Very simple. Here we have N1 moles of A, N2 moles of B. Both of them are colliding. Very good. This means to say there is some contribution because of gas A. There is some contribution because of B. You said, yes, sir. Very good. Correct. Because gas A moles will have their own collision. Gas B will have their own collision. This means to say total pressure of a gaseous mixture is dependent upon individual number of moles of gases. That gas which has more number of moles will have more pressure. That gas which is having less number of moles will have less pressure. Right? Now, suppose, for example, if you are saying, sir, if you talk about total pressure, this must be equal to summation of all these things. That means whenever we are saying PV is equal to nRT, then here in this case we are having mixture of gases. Then in that case, in total system, what we can say, sir, suppose for example, if I take total number of moles in total, right? This must be equal to N1 plus N2, right? Plus dash dash dash. Now here take a break. Remember, N1 plus N2 is sometimes correct, N1 plus N2 is sometimes wrong. Sir, what is the problem? The problem is, suppose for example, if the gases which we are combining A and B do not react chemically, they simply go and dance, do not react with each other, then my statement is correct. Total number of moles N1 plus N2. But suppose, for example, if they are reacting together, then what happens? Number of moles may change, may change. For example, N2 plus 3H2 gives you 2NH3. N2 plus 3H2, how many moles? 4. Right? Gives you 2NH3. How many moles? 2 moles. 4 are going to 2. Right? Carbon monoxide plus half mole of oxygen gives you 1 mole of carbon dioxide. 1.5 gives you 1. That means, suppose for example, if I am writing N total is equal to N1 plus N2, indirectly I am accepting one thing. What I am accepting? I am accepting that the gas A and gas B are chemically non-reacting. Yes, the law which we are going to discuss today is applicable only in case of chemically non-reacting gases. If volume is constant, temperature is constant, right? Come on. What is N? PV by RT. What is this P? Total P. What is this V? As it is same, sir, because volume is constant, by RT. R, universal gas constant. T, I am keeping this temperature constant. Come on. N1. P1VRT. Now how to write P1V by RT? Sir, what is this small p? Small p is called partial pressure. Okay, sir, take a break. What is pressure? What is partial pressure? Pressure means the property of individual molecule. Gas A, pressure of gas A. Gas B, pressure of gas B. No, 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 no. I am having mixture of gas A and gas B. Then in that mixture, what is contribution of gas A? Is called partial pressure of gas A. What is contribution of gas B? Is called partial pressure of gas B. Are you able to understand? If suppose, for example, you are saying that, sir, I have given certain amount as a charity in mask, then you are giving, say, for example, X rupees, another fellow is giving Y rupees, another fellow is giving Z rupees, then they are having their contribution. That contribution is called partial value towards total value, right? Suppose, for example, someone says today, I am in need of X plus Y plus Z amount for something to construct in the mask. Then, okay, come on, X from my side, Y from this side, Z from that side. This is called partial. That pressure is known as partial pressure, which is measured for a gas in mixture of gases. What is your partial contribution? Sir, my amount is X. In how much? X plus Y plus Z. Are you able to understand? Yes, I have given 20 rupees, another fellow given 30 rupees, another fellow given 50 rupees. Total is 100. What is my contribution? 20 by 100. What is 20 called? Partial pressure. What is 100 called? Total pressure. Therefore, remember that if I am writing P, it is pressure. But when I write small p, partial pressure. What is partial pressure? Partial pressure is pressure of a gas in mixture of gases. We write in the notes. Plus N2. What is N2? Nothing, sir. Partial pressure of second gas, RT. Okay, nice. You are saying volume is constant. Cut it. You are saying temperature is constant. Cut it. This implies what we got. A very simple conclusion, sir. This means to say total pressure of gaseous mixture is equal to sum of partial pressures. Partial pressure, small p, right? In common language up to school level, what is this P beta? Teacher told you. Teacher, this is capital P. Beta, write down small p. Teacher, this is small. Size will not give you capital letter and small letter. This is capital P and this is a small p, writing bigger than that one. But it is called small p because of writing. Enjoy these things which we don't know. Okay, right. That is beauty of life. Sigma pressure. What is that? Depending upon the number of gases, P1 plus P2 plus P2 dash 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 Pn. Okay. What is PT? Total pressure. What is partial pressure? Come on. Partial pressure of a gas is its pressure in mixture of gases. Pressure of a gas in mixture of gases. This is called partial pressure. Right? Now, what is this law? This law is known as Dalton's law of partial pressure. Yes. Okay. Dalton's law of partial pressure. Now, how to proceed further? Very simple, sir. Let us try to write down the statement of Dalton's law of partial pressure. What Dalton's law says, listen carefully. In case of chemically non-reacting gases, compulsory word is chemically non-reacting gases, because once they chemically react, this equation is wrong. N1 plus N2 is not correct. Therefore, in case of chemically non-reacting gases at constant volume and temperature, total pressure of a gaseous mixture is sum, yes, of their individual pressure. What is the name of individual pressure? Partial pressure. Yes. But condition is they should not react chemically. Condition is volume should be constant. Condition is temperature must be constant. If it is so, yes, we can enjoy the game. Next one. Okay, sir, you are saying chemically non-reactive. Which type of gases? If there is no chemical reaction. For example, shall I say noble gas plus any other gas? Noble gas means what? Sir, they do not react chemically. Therefore, no reaction. When there is no reaction, Dalton's law is applicable. No reaction, Dalton's law is applicable. Okay, sir, no problem. H2 plus Cl2. Remember that these two fellows, when they are kept in dark, they do not react. If you keep them till your completion of IIT, from intermediate to IIT, they say, no, we don't want to react because we don't have energy supplied. Therefore, no chemical reaction. If there is no chemical reaction, Dalton's law is applicable. No, sir. Take H2 and Cl2 and pass sunlight. Okay. H mu, atomic structure, beginning classes. Photon energy. Then what happens? Reaction takes place. Therefore, Dalton's law is what? Not applicable. Go back to your 10th class. What your teacher taught you? Beta methane plus chlorine. And what was the heading she was written? At that time, she has written halogenation of alkanes, right? Suppose, for example, if you take halogenation of alkanes in dark, no chemical reaction. If though there is no reaction, Dalton's law is applicable. Suppose, for example, no, I want to have chemical reaction. What she told you? She said, take sunlight. And then she has given a name, photochemical reaction. In presence of sunlight, reaction do take place. Therefore, Dalton's law is not applicable. Similarly, suppose if you want to enjoy these fellows, nitrogen and oxygen. Nitrogen has triple bond, requires more energy to break. Oxygen has double bond, covalent bond, not James bond, covalent bond. Then you are having a requirement of 118 kilocalories of energy. And for nitrogen, 225 kilocalories of energy. They demand very large amount of energy. and you are trying the reaction at room temperature. They say, no, we don't want to react because we require more amount of energy. No reaction means Dalton's law is applicable. However, if you take 300 degrees centigrade temperature or electric arc, then not 300, 3000 degrees centigrade, then reaction takes place. Dalton's law is not applicable wherever there is a chemical reaction, right? Hence, whenever we talk about Dalton's law of partial pressure, we say we should have chemically non-reacting gases. Okay, sir, nice. Let us go to another enjoyment of Dalton's law. Suppose, for example, if we are discussing Dalton's law of partial pressure, then what we can say, PV is equal to nRT. No problem. Suppose, for example, I have taken uh, PV is equal to nRT. Are you able to understand here? I have written small p. Okay, sir, you are writing small p means you are talking about partial pressure of any fellow. Say, for example, A. If it is partial pressure of A, this is number of moles of A. Volume of vessel constant. RNT always constant in this process. No, sir. I want to talk about total P. No problem. Total pressure into volume, same volume. What is this here? Total number of moles into R. Equation 1, equation 2, divide them. What happens? Nothing will happen, sir. PA by PT. What is partial pressure PA? Partial pressure of A. What is capital PT? Total pressure of mixture is equal to volume gets cancelled, R and T gets cancelled. We are left over with number of moles of A by sigma m. Okay, okay. Something out of total. Sir, shall I call this as mole fraction? Why not? This implies we got a new statement. Partial pressure of A is equal to PT, not PT Usha, total pressure into mole fraction of A. Sir, PT is a constant. Total pressure of mixture is constant. This implies if you remove the constant, partial pressure of A is directly proportional to mole fraction of A. So instead of saying A, we can say P1 is proportional to X1, P2 proportional to Px2, and so on. Therefore, partial pressure of a component of gas, listen carefully, partial pressure of a component of gas is directly proportional to its mole fraction. Yes, we got a conclusion from Dalton's law that partial pressure of a gas in mixture of gases is proportional to its mole fraction. This is in second year chapter. We read one chapter. We are going to read it if available both of together, known as Raoult's law. Raoult's law says partial pressure of each component of solution is directly proportional to mole fraction, its mole fraction. Here I am saying partial pressure of a gas in mixture of gases is proportional to mole fraction of that gas. What is the meaning of mole fraction? Contribution, right? With respect to total contribution, what is that? It is called as Raoult's law, right? Take down this, then we'll proceed to next slide. Go ahead. Is it over? Okay, go ahead. Go ahead. Is it over? Fine. Very good. Now, this is one side of the photograph of Dalton. The other side of the photograph is very beautiful with respect to IIT examination point of view. They can ask a question. And what is that question and how it is framed like this? Enjoy that game. Suppose, for example, I am having a container. In this container, suppose I have taken certain amount of gas. This is a piston, right? Here I am having gas. Now attach a manometer. Listen carefully, listen carefully. Attach a manometer. Once you attach a manometer, at time t is equal to 0, when you just now started the experiment, there will be some pressure, some reading. This reading is known as pressure of gas A. We don't use the word partial because there is only one gas. Partial word should come whenever we have mixture of gases. Come on. Now what I have taken in this container through in say for example injector, I have added certain amount of water. I am saying certain amount of water. That fellow say liter of water, 2 liters of water, few drops of water, all one and same. All one and same. Whatever he says, it's okay. Once you're adding water, just after insertion of water, see the reading. Sir, reading is same. Nice. Then after 5 minutes, check the reading. 5 minutes, 5 minutes. Every 5 minutes interval, check the reading. Sir, the reading of pressure is increasing. Okay, increasing. What is the meaning of that? This means to say the gas molecules are increasing. How it is possible? Very simple, sir. The gas molecules which are here along with water, they will try to undergo evaporation. Yes, these water molecules will convert them into vapors. Therefore, more and more vapors are formed. And those vapors will try to move up. And as they go up, they will hit to the wall of the container. At that particular stage, there will be something known as condensation. You might have seen some water droplets available beneath, under the, right, the lid, which is used by your mother when she is in kitchen. You just open the lid. If suppose rice is cooking, then below that lid there will be certain beautiful droplets available. What is that? Condensed form of steam. That is called condensation. This is known as evaporation. This is known as condensation. Once you are having this one, pressure is slowly increasing, but it is very much surprising to you that after 20, 30, say for example, 30 minutes, reading is constant. No further reading is changing up to 5, 10, 20, 30, 50. Yes, sir, up to 30, it goes on. Once you are at 30, suppose, for example, it becomes constant. What is the problem, sir? The problem is there is some process known as evaporation. At the beginning, we have more evaporation, and at the beginning, we have zero condensation. But when these molecules will go, vapors of water will go, hit to the piston, they will condense. Now, slowly, rate of condensation also increases. Okay, sir, are you talking about rate of forward and backward? Yes, you are right. I am talking about rate of forward reaction, but it is now in this topic called rate of evaporation and rate of condensation, backward reaction. At particular time, they become equal. When they become equal, as many vapors are formed, so many are condensed to water. That means reaction is going on, no net change takes place. Reaction is going on, no net change takes place. That type of step is called equilibrium. And the pressure here in this case is called vapor pressure, or I can say total pressure of system. Now I can say, sir, after 30 minutes, the pressure is called total pressure. Okay, nice. Now the question is why you are calling total, sir? If suppose, for example, you are saying pressure, then you can say, sir, there is some value of pressure. But why you are saying the word total pressure? Answer is here we are having two substances together. What who they are? P total is equal to total pressure of system is equal to partial pressure of number one. Who was there? Dry gas. First of all, when water is not injected inside, it is called dry gas. Once water has been injected, and after 30 minutes, when the pressure is constant, it is called moist gas. Moist gas. And therefore, this total pressure is pressure of moist gas. And moist gas is having two substances. Number one, dry gas. Number two, water vapors. Are they chemically reacting? No, sir, they are not chemically reacting. No, sir, they can also chemically react. Yes, if suppose they are chemically reacting, don't apply Dalton's law. For example, carbon dioxide plus water, carbonic acid. Don't apply Dalton's law. Ammonia plus water. Don't apply ammonium hydroxide is formed. Therefore, if suppose you are having gases which do not react chemically with water, then Dalton's law is applicable. So partial pressure of dry gas plus what is this? Partial pressure of water vapors. Yes, sir. Partial pressure of water vapors is scientifically known as what? Yes, aqueous tension. Today we are learning a new point in our life, aqueous tension. What is aqueous tension? Very simple, sir. Aqueous tension is pressure of, it is pressure of water vapors over its surface. Yes. Okay. Now, that means Dalton's law of partial pressure is applicable to find out aqueous tension. This is one of the application of Dalton's law. Achha. By the way, in the previous classes, I was repeatedly saying that Boyle's law, Charles' law, Avogadro's law, and gas equation, PV is equal to NRT, not applicable for moist gases. They are applicable only for dry gases. For example, Boyle's law. Okay, let us enjoy beautiful way of writing Avogadro's law, Boyle's law, Charles' law, and PV is equal to nRT are useful only for dry gases. Whereas Dalton's law is applicable in case of moist gas. Remember, Dalton's law is applicable in case of moist gases, right? Now, okay, sir, I got new information known as aqueous tension. Very good. What is aqueous tension? I know it, sir. I have definition. It is the pressure of water vapors over its surface. Okay. If it is so, then I am having a problem. What are the factors upon which aqueous tension depends? What are the factors with which aqueous tension is independent? Very good. Remember, aqueous tension depends only, yes, no other factor, only upon temperature. As, as you increase the temperature, aqueous tension also increases. What is that? Gay-Lussac's law. Pressure is directly proportional to absolute temperature. Achha sir, okay. If it is asked as independent, examiner is much more interested in this because you people are very much fond of taking -1 mark here in this case. For example, he will ask you, beta, whether the aqueous tension depends upon quantity of water. Your mind says, yes, sir. If quantity is more, vapor pressure is more. Quantity is less, vapor pressure is less. Remember, it is independent of quantity of water, right? Okay. Next, that fellow will ask you a question, beta, whether it depends upon surface area. You said, no, I don't know. Tell me first of all, what is surface area? The examiner shows you this figure. Beta, surface area means water is taken in this container and water is taken in this container. If suppose water is available here like this and water is available here like this, then what happens to aqueous tension? You will shout, okay, sir, it depends upon, here we have less surface area, here we have more surface area. Examiner says, very good, I'll give you -1 mark and I'll give you answer that it is independent. Remember that the aqueous tension is independent of surface area. Sir, something is wrong. Why you are giving negative mark? How can you say all these things? Yes, I can say this because pressure is defined as force per unit area, 1 centimeter, 1 centimeter, not necessarily discuss whole area. Therefore, remember that the aqueous tension is independent of quantity of water, it is independent of surface area. Okay. When it is independent of the surface area, when you have given correct answer to the examiner, examiner says, okay, how I should give this boy -1 mark. He will change the sentence. Okay, better tell me one thing. Aqueous tension depends upon shape of vessel. Yes or no? Shape of vessel. He is indirectly asking surface area only, because if you change the shape of vessel, surface area changes. You people are genius, therefore you say, okay, examiner, no problem. I'll say correct answer. It is independent of shape of vessel also. Hence, remember that the aqueous tension is independent of quantity of water, independent of surface area, independent of shape of vessel, and all other factors. It depends only, only, only upon temperature. Okay. Now that is something known as Mr. Dalton. Now you have to honor Dalton today evening at home. How to honor? Today, write down in your notes, systematically take a book, write down applications of Dalton's law of partial pressure or uses. Go ahead. Right? Is it over? Go ahead, write down. So hey, if it is over, read once the whole notes. Today what we have done, those who are having habit of fast writing, they should take advantage of that. Just turn the pages back and start from the beginning of Dalton's law of partial pressure. Try to understand and read. If you have doubt, you can ask. Take advantage of time. Okay, fine. That is the end of Dalton's law of partial pressure. We have one more law to be discussed that we'll discuss in the next class tomorrow. Thank you. Assalamu alaikum.